Hi, everyone. Good morning.
Hello.
As Ana point out, I'm Elton Simões Gomes. I'm editor of
Veio
Chute,
cada de um lado.
the tech and science
ligado?
channel of UOL,
Veio
one
cada-
of the biggest news outlets in Brazil. As everyone knows, agriculture industry relies very much on weather conditions, as we speaking outside. But nowadays, more than ever, these companies have to be superpowered in order to face the challenge of climate. And in this panel, I think we're going to discuss about how leading companies in agri-tech are using AI in order to promote the future agriculture revolution. I would like you both describe what your company are doing in order to do that.
Perfect. I can start. So Traive, we are one of the first native AI fintechs. What we do, we are in the field of research and development for graph AI with LLMs. We use this technology in order to make a prediction about the agricultural market and derive all the cash flow components, ability to pay, as well as willingness to pay of a farmer, agri-tailer, co-op, trading house, in order to help the capital market, in order to have a better tools to risk assess this industry and understand them so they can deploy more capital. And we build on top of that applications which connects financial industries and capital markets in order to transact credit lines, insurance, in order to promote better rates and less collateralization, which is often needed.
Thank you so much for having me. Please let me know if you can hear me well. I'm the CEO of La Firma. We use satellite data to forecast environmental risk. That includes erosion, landslides, flooding, particularly in Puerto Rico, but we can do that throughout the world. Aside from building these models to forecast what the soil loss is going to be on your farm, how will different soil formations or conservation practices will perform if implemented on your farm or whatever terrain you may have. We do that throughout the entire landscape. So not only in agricultural farmlands, we do that in rural areas, we do that in urban areas as well as part of our effort to conserve any type of natural land, but as well, of course, our urban assets, our built assets.
Since everyone knows what your company does, I would like to do the first question. Let's start with you, Aline. How big data is being used to improve the farm in general?
This question is very interesting. In theory, big data is, data in a general way is helping farmers to get better climatic predictions in order to have better machinery with more precision to make applications of fertilizer. Everybody knows about that, but the reality being is that actually the agriculture sector is one of the most and the least, I would say, big data is structured and available industries in the world. People oftentimes think that, okay, agriculture is so large, so vast, so it's a third of the jobs in the world is within the agriculture and food supply chains, but yet, actually, I would say that big data is not as present or it's not as structured enough for the classic AI deep learning models, which are very data intensive in order to perform in all domains very well. It is, I would say that it is changing. This industry is coming. I feel that agricultural players right now see the potential of that and are doing a better job on labeling data and store data. But yet I think that the transformation of that is still lagging behind on where we could have been if data was very structured, organized, and stored for companies like ours to do it.
Aline talked a lot about precision. What is your thoughts about that?
I think I'm completely. I agree completely with Aline. The lack of data introduces a lot of variables into the agriculture process, which we are unable to predict. From the financial side, from the production side, from where you plant your crops, how do you maximize your farmland? Those are very important topics, which right now our resolution for geospatial analysis of those attributes are 30 meters. 30 meters is incredibly broad. You can't really plan on how water disperses throughout the landscape. How do you maximize their natural features with that satellite resolution? What we do in Terra Firma is we actually increase the precision and make that broadly available to the rest of the population, whether you're a farmer, whether you're in the financial pipeline, whether you're in the logistics pipeline of how you make this, the production of crops feasible throughout, not only in production, but when you export that, when you package it, when you contact your financial creditors. How do you express to them the value of your land aside from only how many crops have you produced?
When I hear you, Aline and Alejandro, I just think only big companies can do that. But smaller companies, smaller farms can be empowered to use AI and leverage their benefits from this technology?
I would say that there are two angles, perhaps, of your question. If your question is, can smaller farmers or smaller agricultural companies benefit from this technology, I would say that they are the ones that could best take the advantage. Of course, you need to think about in which kind of domain, right? Whereas I feel that the larger players, they sit before the smaller players for the pure reason that they have better data. They usually have more structured data because as you start to scale your agriculture or your farming operation, I mean, companies, they tend to invest on systems of records and ERP. Therefore, you have the data, right? Where if you're a small farmer, you don't care about that. But this is interesting, Elton, because we understand that for this technology to go, exactly the field of where we are in the research and development in AI in Traive is exactly how you bring the precision of these deep neural networks in very sparse, fragmented data dimensions, like for small farmers, in order to benefit, because otherwise it's going to be a very long tail for the adoption of AI.
Yeah. Sorry.
Yeah.
Can you repeat the question again? I'm having trouble hearing across the stage. Is the situation?
Yeah.
I'm wondering if it's that easy to smaller companies to be empowered to use AI and obtain some advantage of the use of this technology.
Yeah, the resources to produce models for AI are quite resource intensive. You need servers, you need a repository of data that's quite immense. So, of course, the larger companies are able to harness that data, whether it's internally, whether it's externally, to actually train these models to generate viable results or useful results. The difference right now in the timeline we are incurring is that data really hasn't been gathered, especially for the agriculture industry. So large agricultural producers have data that they're going back to and trying to understand how to use it right now. But the smaller companies are going into the field of environmental sciences, not only agriculture, but the environmental sciences and understanding how environmental risks from the physics side, purely from the environmental side, not from the logistics or financial side. And that has a value as well. That has a much broader value that is not going necessarily into how do you make your farmland more viable for predators, but how can you maximize it? How can you protect it from different risks, from different sicknesses on the plants. I'm having trouble translating. Sorry, but understanding what are the different risks in terms of drought, in terms of hurricanes, in terms of just soil loss, which is the primary risk that farmers need to tend to, because it is their livelihoods. It is literally their land that is becoming infertile due to soil loss. Yes.
We were talking backstage how difficult it's to collect the data despite of the size of your clients. I would like you to tell us about what is the key challenge in order to navigate in big data. It's the data, or how you train your models, how you build your models. What is it?
It's always usually the data. And let me give you a concrete example. I mean, just recent, there was a new open source large language model launched by Databricks that they outbeat OpenAI's model, or they claim that they outbeat the others, right? It's ultimately, it's always about the data pipes, clearing, labeling, having good data quality, which is a challenge. In our case, this is a little bit more magnified because we, at Traive, we model the system. And we model weather. I mean, we get data from companies like from Alejandro, that models, they're very good on climate models. We model bases, we model logistics, we model credit risk, we model financial risks. It's a combination of a lot of data sets, which they comes from different sources. They have different structures, they have different frequency. And in addition to that, we integrate with ERP and the data, so this AI can reason within that. And challenge is that, especially in Brazil, most of the ERP systems, their architecture or how they were done, they are highly customizable. So there is something which is the semantics, right? Sometimes like you have different names for the same thing, and how people register, like farm can be propriedade or fazenda, like two words. They mean the same thing, but for the AI machine, like you need to give the context, right? So we ended up spending, but we found out ultimately, because we needed to be so efficient on labeling and having to do data, we became very good on building an ontology engine in order to stitch that data in to do that. As well as, this is why our research has been around graphical neural networks applied to small data sets, so we could extract the most out of a smaller data set, because it is a challenge, the sparsity and the volume of data assets, because not all commodities and not all regions, you can model them in the same way. So people can say, hey, you have a bunch of soybean data around the world. Yeah, but soybean in Mato Grosso is not the same as soybean in US nor in Ukraine, right? There are some aspects, and it is a challenging, and oftentimes you find yourself having to invest a lot of resources in your data team. So methods, ultimately, they become as a consequence of the data. And that is the key of any model.
Yeah, the data part is definitely the most, is the basis of where you train the LLM model or any type of AI model. And it's the same story of garbage in, garbage out. If you put garbage into the model, it's going to produce unviable results or unusable results. The importance of what Alina just mentioned right at the end is the use of the data. Why is data so different across these sectors? It's because the use for it, or the purpose of how it is gathered, is very different. Soybeans, like she said, in Ukraine are very different from soybeans here in Brazil or wherever, and different crops have different. How you measure the data of which you're producing is very different across the world, and having to tie it back or having to understand what are the commonalities across those data sets usually eliminates around 80% of the usefulness of it. So you're eliminating why it was produced. You're eliminating categories of it. The names, how they are categorized, are very different across countries, across how units of measurements, what is measured for what it is measured. The reason we in Terra Firma insist on the physics of it is because we believe that is the base point. Understanding how water moves, how wind moves, how how the sun moves as well, how different solar exposures operate throughout your farmland, throughout your landscapes. That is, to me, at least to our company, the most basic thing we can measure. That is commonly useful across the board for any country. So that's why we are essentially focusing on that level of the data we are harnessing.
Okay, let's talk about another kind of challenge. Your both company are international and you move data from country to country. And I would like to know what is the challenge of uh, uh, collaboration with data in order to promote the food and, and global security.
Wow, yeah, that's an interesting question. So you're right. Every country, Mexico, US, Brazil, they have all different nuances in terms of how you can make the data and where you have a consent or you have to ask the user, how you ask the user about the consents, when it expires. Today, what we do, we give full transparency to the users how we're going to be using their data. I mean, and it's their choice ultimately, how to the extent that they want to share. But talking to your point about how we can sharing data could actually promote better understanding of these models for managing food supply chains. Absolutely, right? And this is one of the things that recently we have been discussing with the Brazilian government. I mean, to the extent that, hey, CONAB and BRAPA, which are the agencies that has a bunch of data, we're partnering with companies that we could collect data from them, from USDA, from FAO, right, in order to train models that can better reason within the supply chains would be something theoretical, which is very advantageous to our organization. I mean, let's see if we can do it.
What about you, Ale?
I think the basic question within that is, can your country feed itself? And I think being in Brazil is very interesting because, of course, you have the farmland to feed yourself. But there's a part of geopolitics, which is countries that cannot really feed itself, like the farmlands, like the landscape doesn't produce the capacity for the people who live there to actually live there. Puerto Rico is a very interesting place to live because we import 80% of our food. However, our landscapes are tropical. We have 11 of the different soil types available in the world, which are 12 in total. And for geopolitical reasons with the US, we don't have the capacity to feed ourselves. So that's very interesting in terms of how you look at food security, because it's not only the capacity to produce viable farmland or produce crops. It is actually the political landscape and the political capacity, the political will to create the engine, the economic engine to foster wide-scale agricultural lands in order to produce the logistics internally for any country to be able to protect their food security.
Well, we're running out of time, but I would like you to recommend what do you recommend to people and companies that are in the beginning of this journey of big data and AI? Why they have to do first?
Read the basics. Try to understand how these models, their reasoning, their limitations, and their power, so you can
Not
make decisions.
so basic.
No, there are like a good literature out there and like a self-explanatory. It's not a rocket science, but that's my recommendation.
Alejandro?
Yeah, I think the current trend of AI is going towards broadening knowledge bases. Like if you enter any word in ChatGPT or wherever it may be, it correlates that with databases that are worldwide, whether it's Brazil, whether it's the US, whether it's wherever it may be. I think harnessing the local, there's a power in that which is going to come into the future. That's why we believe in geospatial analysis, in understanding the local conditions of whatever food security topic we're going to be solving, climate change topic we're going to be solving, is going to be solved locally. It's going to be solved on the ground with the implementations on the ground, and needs to be understand, and we need to understand what are those realities on the ground. So that's why, at least for us, we think, yes, understanding the global scale from that AI allows us, but in the future look towards implementations on the local scale and in local knowledge bases.
That's it. Thank you, guys. Thank you, Aline. Thank you, Alejandro.